Hello and welcome back. I thought I'd give you, since we did parts A and B, we might as well do C in investigation for question 4, because I feel like these are really important. Part C discusses a skier who starts from the position 2.50, and our units here are kilometers, 2.50, and now the skier moves clockwise 5 kilometers for 5 kilometers. So, all right, this arc length is 5 kilometers. And now we're asked to determine the ordered pair measured in radii. So if we were in radii for part I, in radii or radians, that would be cosine of the arc traveled. Now in this case, it's moving 5 kilometers in the negative direction, so we would say that he has clockwise motion we consider negative. And so we're going to use cosine of negative 5 in arc divided by 2.5 and sine of negative 5 over 2.5. Okay, and that would give us this ordered pair, negative 0.416 and negative 0.909. Okay. Now, part 2 asks us to relate this to units of kilometers. So now, again, this would, if we made the mistake of attempting to plot these points, negative 0.416, negative 0.909. So in our y coordinate in terms of radii, if we were to say, oh, this is the point 0.909, well, in this circle our radius is 2.5, and very clearly that wouldn't make sense. 0.9 in y being roughly about there. So all we have to do to adapt this to our units, the units of kilometers, is to get this ordered pair is multiply those values, 2.5 times the cosine of, what is this ratio? Negative 2, that would be negative 5 over 2.5, negative 2, comma 2.5, sine of negative 2, and that would give us the values negative 1.040, comma negative 2.273 for part I. And that makes sense, that we're approximately 2.273 kilometers away, right, from the horizontal diameter, and we are about 1.040 units away from the vertical diameter. Okay, now for Module 4, Investigation 4, number 6, I suppose I'll pose a question to you. So if we're considering a circle with, make sure I'm in black here, radius 1, so that would be, no, don't do that. Let me get my draw tool. A circle with radius 1, and my question to you all is, are there points along this circular path where are there multiple points along the circular path where our, say, horizontal distance from the vertical diameter and our vertical distance from the horizontal diameter are going to be equal? And the answer to that question is, well, yes, there certainly is. If we were to draw a line directly across, if we were over here in quadrant 2, this vertical distance would match this vertical distance, and of course this horizontal distance would match this horizontal distance, and so forth. In fact, you might be thinking, well, wouldn't I could conceive of a scenario where if I drew these x shapes symmetrically about the origin, of course there are going to be an infinite number of points, ways I could draw this x symmetrically about the origin, whereby these horizontal distances are the same and the vertical distances are the same. Okay. So in part A, they're asking us to construct angles on the unit circle. So we have a unit circle, right? This is 1, 0. Our radius is 1. Of pi over 6, that's 1/6 of pi. Just as a reminder, 1/6 of pi is pi over 6. Right? So that would be, we know there are 2 pi radians of openness subtending the entire circumference of a circle. So 1 pi would be a half of a revolution around the circle, and 1/6 of pi would be about right there. It's about a 30-degree angle. That would be our pi over 6. And then 5 pi over 6, that would be 5/6 of pi. So that would be 1/6 of pi away from the negative x-axis, so that would be here. And then you see where this is going. They asked you to do 7/6 of pi, that would be 1/6 of pi below the horizontal in quadrant 3. So I can just kind of extend that line. And then 11/6 of pi, that would be pi over 6 away from 12 pi over 6, or 2 pi. So again, I could extend this line in this fashion. And we would have completed number 6a, right? Where this would be 5 pi over 6, 7 pi over 6, and then we would go all the way around until we're 1/6 of pi away from the horizontal, and that would be our 11 pi over 6 radian measure. Okay, moving on to part B, it says we're going to use our calculators now to determine these coordinates for this is a pi over 6 radian measure, and discuss what the meaning of those coordinates. Hopefully by now we have a sense for what this quantity represents. So if we did cosine of pi over 6 and sine of pi over 6, okay, maybe I can draw that clearer. Very hard to draw nicely on this thing. Sine of pi over 6. And of course that would give us 0.866. Of course, if we're not using a computer algebra system based calculator, we'll get these decimal quantities. Just again, that's our angle, pi over 6. This is actually radical 3 over 2, and this is 1/2, of course. And what's the meaning of that? Well, that tells us that this point is a half of a radius length above the horizontal diameter, and 86.6% of a radius length to the right of the vertical. So now in part C, they're asking us to determine the coordinates that correspond to angular change of 5 pi over 6, 7 pi over 6, and 11 pi over 6. So for 5 pi over 6, that's here. Of course, we know, my drawing is terrible, right? That distance should be the same as that, but what's going to be different? What's going to be different is, well, nothing, because we're still above, what's going to be different here? That's what I meant to ask, right? If we're still above the horizontal diameter, we expect that the value of the sine to be exactly the same, right? Because we're still above the horizontal diameter. But what's going to be different about the cosine is, well, since we're now no longer to the right of the horizontal diameter, we are to its left, we're going to get a negative value. And when we plug cosine of 5 pi over 6 into our calculators, we will get, of course, negative 0.866, and we will get the same value for the sine, 0.5. For 7 pi over 6, what's going to be true now? What's going to be true now is we're going to be below the horizontal diameter and to the left of the vertical diameter, right? And so we're going to get the same values we got here, only now they're both going to be negative. Negative 0.866 and negative 1/2. And for this ordered pair, that would be for going this far around the circle, a radian measure of 11 pi 6 we'll get for this ordered pair. Well, now we're to the right of the vertical diameter, so the cosine will again be positive, but the sine will be negative because we're below this horizontal. And so here we will get 0.866 and negative 0.5. We got a little longer than I wanted to in this video, but that concludes our discussion of Investigation 4. I'll have some videos posted soon for Investigation 5. See you then.